Okay, my friends, so one last kind of concrete example about this, which I think will apply to more of us than craps, which is insurance, and I'm going to use life insurance. So I'm going to tie it back to craps, because really, life insurance, gambling, they're all the same when it comes to averaging. There's a payout for winning, there's a payout for losing, and there are probabilities to each of those things. So I did a little digging after the last video, and I stumbled upon the Social Security's actuarial life table. And this is interesting. They give us, this is updated as of 2016, 2017, haven't updated it since then, which is fine. I think it probably gets us close enough. It will be interesting to see how these numbers change after COVID though, but whatever. It gives the age of males and females in the United States and the chance they die at given years. So this year I'm 48. There, I highlighted mine right there. So this tells me there's actually a 0.4% chance that a 48-year-old dude is going to die this year. I guess they assume that by looking at last year's stats and realizing that 92,893 48-year-old guys died last year out of whatever the grand total was.
Just a quick aside as we continue this problem. That 0.4% that I just mentioned there is all 48-year-old males in America. And there are a lot of qualitative and quantitative differences between all 48-year-old males in America. For example, I fit a certain ethnic group. I fit a certain health group. I fit a certain dietary group. I fit a certain environmental group where I live. Where I did live, actually. I mean, I'm a 48-year-old male this year who spent 30 of his years on the East Coast and then the last 18 or so out here out west. So, I mean, there's all these factors that go into my well-being and the chance of my dying. So when I'm using 0.4%, we're using an average, which is going to get us an average of all 48-year-olds. Realize, though, that individual 48-year-olds might have a higher or lower chance of dying depending on those environmental factors. The same discussion has happened recently during this whole COVID pandemic when people are like, what is the rate of contracting COVID? Well, it depends. And I know that seems like a cop-out to say it depends. But it really does depend on many, many factors: environmental, health, ethnicity, whatever. And as you spend more and more time in statistics classes, you begin to realize just how important it is to try to measure that which depends in the situations. But as far as learning how to average a distribution, we'll use the average death rate of 0.4% and call it good.
So I'm going to actually copy that rate because we're going to need that later. That's the chance that I die when I'm 48, which means the other 99.6% is going to be the chance that I live. That's going to be important. Now, if I'm going to take a life insurance policy out, I also have to know how much I'm going to take it out for. And I did a little Googling around just to kind of goof, and I just stumbled upon this website, a 1-year non-renewable term life insurance policy. It doesn't give me any amount to choose from, but it does give me rates. And for a 48-year-old dude, my rate's down here. It's going to charge me 63 cents per $1,000 of policy. And I'm assuming that's per month. It doesn't say that in there, but we'll come back to why that makes sense in a second. There's a lot of assumptions going on in these web pages that I'm kind of scrolling through. Anyway, let's go back to our spreadsheet because I want to set this up using our spreadsheet. This is the Don't Pass Bet spreadsheet. And you know what I'm going to do? I'm just going to go ahead and move or copy, create a copy. And I'm going to make this the Sean Life Insurance. Rename life insurance Sean. Okay, and we're gonna have to update this sheet. I'm actually gonna delete all this other stuff over here because I don't think we need to worry about that. We'll redo that as we go. There's not gonna be a push. You either live or I die. Either live or I die. So I'm gonna take out some of this stuff. Okay, if I live or if I die. I can't put an exclamation point there because I'm not excited about the thought of that. Okay, and this is going to be insurance. So You know what? I'm going to leave that as amount 1. We'll come back to that column. The column I want to talk about right now is the chances. So I know the chance of me dying. I pulled that off of the Social Security website. It's that 0.004178, which means the chance that I live is everything else. That makes them sum to 100%. Okay, good. Now, how much am I going to pay for this policy, and how much is the policy going to pay out? Well, I just got done saying that if you look over here, it doesn't tell you how much the policy's for. So let's just make up a number. Let's say that the number is $100,000. Let's just make it $100,000. I'm going to take a nice $100,000 policy out for a year. That way my family's covered in case I die in the next year for $100,000. Now remember, down here, they're going to charge me 63 cents for every $1,000 of the policy. This is kind of nice. Using 100,000 is nice, because if it's 63 cents for every $1,000, that's just going to be 63 bucks a month. So I have to pay 63 bucks a month towards this insurance plan. Now, if I live, I've got to work through this with me now. If I live, I'm going to lose that money that I pay each month. So follow me on this formula. It's going to be negative, because I've lost it, 12 times 63. So I'm going to be in the hole 756 bucks at the end of a year if I stay alive. Hopefully that makes sense. Hopefully that makes sense. 756 bucks because I pay $63 premium 12 months. So that's in the hole 756 bucks. What if I die? Well, if I die, I'm going to have $100,000. Or I guess I won't, because I'll be dead. My family will have $100,000. But we have to take out the fact that I paid for it. So I actually only clear $99,244, or my family only clears $99,244. Now, do you see how this ties into craps? I either win or I lose. Winning, in this case, is a little bit morbid, but winning is the jackpot. That's if I die. That's the win. And losing means I stay alive, because that just means I lost my ante. The ante here is that 756 bucks. That's that. If you think back to craps, that was that $5 ante that we had to pay up each time. Okay? Now we can do the average. We can do the average earnings for this policy by, it's exactly the same way we did it before. All right, we're going to do each X times its corresponding probability. And we're going to drag it down, and then we're going to sum it up. And you can see right away why this is good news for the insurance company, because it's an average loss of about $338, $338 per policy. Which means, on average, people are losing money on this policy, which has to happen, right? That makes sense. That average has to be negative. It's negative for the policy holder, because the insurance company is a company. They have to pay their employees. They have to pay the electricity bill. They have to pay the rent. So they have to be earning money on these policies. Okay, so life insurance, craps, rolling a four-sided die until you get a repeat. Every single one of those scenarios is the same probabilistically and statistically. Let's look at one more video just to wrap this whole idea up.